So today's webinar will be presenting our speaker, who is also our faculty member, Dr. An Hong Ki, with the topic, The Change of Roundabouts, a Smart Intelligent Approach. So before we proceed, I would like to take this opportunity to remind all attendees to fill up the attendance form that will be given during the webinar later on for the e-certificate. So without further ado, I would like to invite our moderator, Dr. Ilya binti Johari, to moderate the webinar for today. So please welcome.
Hello everyone, Assalamualaikum, and a very good morning to all. My name is Ilya, the moderator for today. So I would like to take this opportunity to thank everyone for joining us this lovely Friday morning. So without any further delay, let me introduce our speaker for today, Dr. An Hong Ki. So Dr. An received a PhD in Transport System Engineering from the University of South Australia. Prior to studying for his PhD, he worked as a transportation researcher at the Korea Transport Institute, where he was involved in public transport planning, preliminary feasibility, and metropolitan transport implementation planning. So from 2018 to 2022, Dr. An was an associate professor at the Faculty of Transport Engineering at Huayin Institute of Technology, China. So basically, Dr. An is originally from South Korea. He got his PhD in Australia, and then he went to China to work as a professor, research associate professor. And he is currently working as a senior lecturer here with us at UniMAP. And his research interests are in traffic management and the application of metering system at intersection, smart city, transportation modeling, and public transport system. So let us all welcome Dr. An Hong Ki for his talk entitled The Change of Roundabouts, a Smart Intelligent Approach. So Dr. An, whenever you're ready, the floor is yours.
Okay, hello everyone. Can you hear me? Hello?
Yes, we can hear you clearly, Dr. An.
Okay. My name is An Hong Ki. Then I will share my slide. Okay. Can you see my slide?
Yes.
Yeah.
Okay.
Yes.
Okay. All right. So hello, how are you? My name is An Hong Ki from Civil Engineering. Can you see my slide now?
Yes, Dr. An, can you make it full screen?
Okay. Because I have two screens, so okay. Can you see my slide now? No.
Yeah, we can see your slides, but it's not full screen.
Ah. Okay, what about now? Can you see my full screen? Hello?
I'm not sure if it's just me, but I still cannot see the full screen.
Maybe Dr. An, you can start with the presentation here. Yeah, start.
Now, can you see my full screen?
No.
No.
It's just in the previous state before the starting of the slide. I think it's okay. I think we can
Yeah.
see it clearly here. I
All
think
right,
you can just proceed. Yeah.
Okay. All right. Today I would like to talk about the challenge of roundabout, a smart, intelligent approach. Actually, this is my research area. Then my name is An Hong Ki. Actually, transportation is very new in Malaysian University. When you have a look the definition of transportation, the movement of goods and people from one place to another place. This is definition of transportation. Then why we study this transportation engineering is we need to provide for the safe, rapid, comfortable, and convenient, and economical and environmentally compatible movement of people and goods. So actually, transportation was part of civil engineering in the past. But as you see, at many universities, transportation engineering grew out of civil engineering departments before becoming independent in some cases. Still, in European country and US university, still transportation is part of civil engineering. But 1950s in US and 1950s and 60s UK and 1980s and 90s in Korea and 2000 in China, like a transportation department became an independent department. So nowadays in Korea, totally separated transportation and civil engineering. So when I entered my bachelor degree university, it was Department of Transportation Engineering. Then I studied in the US, also Department of Transportation Engineering, and in Australia, Department of Transportation System Engineering. So nowadays in Korea, we changed the name, Smart City Engineering. So if you want to study in Korea, no more transportation is under civil engineering. So you need to find urban engineering or smart city engineering or transportation engineering. In China, a little bit different. Transportation engineering combined transportation engineering department and vehicle engineering. So like a mechanical engineering. So nowadays, China became a world-leading country in autonomous vehicle, like driverless car. I think this is strategy very successful. All right. So when I was a student, I studied many subjects in transportation engineering. Actually, two big parts. First one is transportation engineering, and second one is transport planning. Transportation engineering include traffic engineering, transportation engineering, traffic control theory, traffic capacity theory, something like this. And transport planning also include road safety, transport economy, ITS, urban public transport or urban railway system, and traffic demand theory or network modeling using microscopy or measure or macro, CIDRA, VSIM, and traffic operation and management and so on. So I got told that even in Malaysian, some of Malaysian university will start master program in road safety engineering from this year. Then they'll be taught around 10 subjects in transportation engineering. Also, Monash from 2026 will start sustainable and smart city engineering. Also, will contain a lot of subjects in transportation engineering. Okay, briefly, we had the subject in transportation. Then after study of transportation, maybe we will be involved in variety of transportation fields like a BRT, bus rapid transit, or we study for pedestrian and bicycle users, or intersection control, or BIS, bus information system, or transport center, something like this. So many fields we can work as traffic and transportation engineers. All right, so let's move on to introduction of my slide. Okay, actually, congestion, we all face this congestion in big cities like Penang, KL. Every day, everywhere, we have this problem. So how to minimize this congestion is actually our challenge. Actually, two conditions we have. First, interrupted flow condition. We can say congestion at intersection. Another congestion at uninterrupted flow condition is highway, because highway there is no like obstacle or signal can block and block vehicle movement. But at intersection, especially signalized intersection, traffic signal can manage traffic movement, right? So we can divide these two conditions. But today, I will talk about intersection, interrupted flow condition. Yet, as I said, this congestion is due to accumulated house wealth plus developments in automobile manufacturing technology. So compared to like in the past, people can afford to own this vehicle easily. So many cities, it become like a social problem. For example, from like a Georgetown to Bayan Lepas, although the distance is like around 15 kilometers, but sometimes during peak hour, it took over 1 hour. This is a huge problem. So how to solve this congestion problem? Simply, we can say we need more facility, like we need more road, we should expand the road, or we need another mode, something like that. But it cannot be a solution because the first stage, yes, until 1960s, European country, Western country thought supply of facility can solve this problem. Then since 1970s, they shifted their perspective to traffic management because new road facilities may potentially generate future traffic demand. As you see the Johari campus, previously we had very limited parking space. Now, okay, we have more spaces, but it will face another congestion problem. This is like we call induced traffic phenomenon. It will generate another demand. So supply of facility cannot be the solution. So now we focus on traffic management has also two types. First one, TDM, traffic demand management, controls traffic demand at the traffic generation step. Today we talk about TSM, traffic system management, attempts to increase performance of existing road facility. We don't need a new facility. We will use existing road facility. This is TSM. So I will briefly introduce you this induced demand. Okay, first photo shows that there are 3 highway lanes. Then it has congestion problem now on the second photo. Then third photo, we expanded one more lane. So it can minimize congestion temporarily, but in the future, it will attract more traffic from other road, like a local road or traffic from off-peak hours or from others or remote. That's why we now should focus on traffic management. All right. So traffic management at intersection. So we need to understand intersection first. Intersection, yes, we see every day intersection. The definition is a junction where several approaches cross or meet. This is intersection. But this intersection is very, very complicated because different modes share the intersection at the same time. So many researchers said already 81% of accidents can be occurred at around intersection, or 75% of injuries related to car at near intersection. Actually, three types of intersection. First, signalized intersection. According to Korea Highway Capacity Manual 2013, this signalized intersection is from UK. Then this is good for over 20,000 vehicles per day. If less than 3,000 vehicles per day, we recommend stop or give way intersection. For stop or give way intersection and signalized intersection, vehicle movement can be managed by signals or stop or give way sign. Then drivers need to follow this. But roundabout is good for between 3,000 and 20,000 vehicles per day daily traffic volume. This roundabout normally suitable for collector road or local street. Also started from UK, then spread to Australia, Malaysia, US, and Korea. 2011, we adapted this roundabout because there are two traffic circles. One is roundabout from UK. Another one is from US, rotary. These two traffic circles appearance is almost similar, but operational principle is totally opposite. At roundabout, entering vehicle should give way to circulating vehicle. However, at rotary, circulating vehicle should give way to entering vehicle. That's why 1990s, US also gave up to use this rotary system. They adapted roundabout. All right. The roundabout, as we know, there is a certain form, central island. So drivers should circulate this island, also need to reduce speed. Then, as I said, roundabout has their own rules, roundabout rules. This roundabout actually many characteristics, but I will introduce you three. First characteristic is critical gap is if entering vehicle needs to enter, they need to find the gap between two circulating vehicles. This time gap we call critical gap or accepted gap. As you see this figure, maybe some people accepted the gap in short time. Then some people rejected the gap even in longer time. So this crossing point can be critical gap. Another characteristic is follow-up headway. This headway is time gap between two entering vehicles. Another one important is lane by lane theory. previously, we calculated roundabout capacity like each approach. Nowadays, we studied each lane has different capacity, so it should be different. For example, if you see the blue arrow, when they enter the roundabout, they need to watch out only for one conflict point here. But for green arrow, need to consider two conflict points. That's why always inner lane is longer than outer lane. Also, we don't recommend to change lane on the circulating lane. If we have no sign before entering roundabout, this is standard rule. Like a blue lane, blue arrow can make left turn or straight. No need, cannot make right turn actually. Then green arrow can make right turn and straight. No left turn is allowed. This is a standard rule. So normally in Australia, before entering roundabout, there is the sign like this. But in Malaysia, still we need to improve, this lane by lane theory, and this we need this sign. All right. Why I introduced you these three characteristics? Because, as I said, previous capacity model only consider how to deal with this weaving area. Nowadays, new capacity model like a CIDRA model, Australia, consider follow-up headway and critical gap can affect roundabout capacity. Also, US model, first one lane roundabout and two lane roundabout capacity model are different. Even left lane, right lane, also they have different capacity model. All right, this roundabout has three major advantages. Because due to keep moving premise, vehicles do not need to stop. So they can decrease like environmental pollution, 29% of CO2 and 21% of NOx. Also, one lane with 4-leg roundabout, the number of conflict is 32, whereas at roundabout, the number become 8. So also safety, for safety, also very, this roundabout is very safe than signalized intersection. So nowadays, in the beginning, I said roundabout is suitable for local and correct road, but nowadays, signalized intersections are replacing by this roundabout even on arterial road for the safety purpose. This roundabout, yes, very good, many advantages it has, but sometimes it also faces congestion problem. So transportation engineers thought through design change, it can be solved. See, from German, a lady studied turbo roundabout. Even the inside of island, the shape is a little bit different. For example, the two-lane, 4-leg roundabout, the number of conflict points is 24 at normal roundabout. But at turbo roundabout, the number is 14. So the conflict possibility can be reduced. Also, flare lane roundabout, slip lane roundabout can increase roundabout capacity. Another design change, suspended or flyover roundabout, and magic roundabout in the UK. 6 roundabouts are mixed together. Another one we call twin roundabout. Also can increase roundabout capacity. But this roundabout, although can increase roundabout capacity, but cannot solve problems caused by unbalanced traffic flow condition. What is unbalanced traffic condition is from the first figure, we can say total volume is 3,000 vehicles per day. So each approach has 750 vehicles per hour. So total 3,000. But right one, same, total 3,000 vehicles. But south approach takes 70% of entering traffic lane, 2,100 vehicles per hour. But another approach, 300, 300, 300. So although they are same, but this is unbalanced traffic condition. It can generate like a congestion problem because vehicles on the dominant major approach cannot enter the roundabout because of this circulating vehicle from west, north, and east approach. So how we solve this problem? Actually, Rami Akselik, Sidra software developer, suggested metering system can solve this unbalanced traffic congestion problem. What is metering system? We install detector on the major approach, and then we install traffic signal on minor approach. When this queue reach the detector, then stay for certain time, signal can be read. Then major vehicles from major approach can have enough gap time, then they can pass. This is metering system concept. But however, this researcher suggested that queue detector location should be between 50 and 120 meters. Well, we don't know 60, 70, 80. We don't know which distance is optimal. Why this is important? Because with the same condition, okay, left photo figure, detector location is at 50 meters. So this roundabout, yes, vehicle movement from east approach can be blocked. So south approach can enter. However, if detector location is 100 meters, still traffic signal is green. It means vehicles from south approach cannot easily find the gap because of this vehicles movement from east approach. That's why detector location is also important at metering roundabout. So I want to introduce you some of my research already published at ISI paper. 2019, I used fuzzy system, fuzzy logic. Then I estimated queuing length at metering roundabout. I formulated queuing length formula with 6 variables. Then I tried to get optimal detector location in 2019. After that, 2020, 2022, I tried to even optimize the signal timing with intelligent algorithm. Then 2023, even I tried to optimize traffic signal timing with multi-objective optimization, because previously in transportation we used 2 typical methods. One is green shield method, which tried to minimize the headway at intersection. Another one is Webster model, try to optimize the delay time. But my research, I tried to optimize capacity, density, delay, number of stops, CO2, and so on at the same time all together. So I tried to find the best cycle length and green time and red time, all these things by using intelligent algorithm. Okay. Then I verify that signal timing based on vSIM microscopic simulation analysis. Then I can say this new technique can enhance roundabout, performance more than previous typical classic method. So today, I briefly introduce you traffic circle was a simple intersection. Then there was some design change methods to increase roundabout capacity. Then nowadays, we use AI algorithm to optimize traffic flow at roundabout. Okay, thank you so much for listening my presentation today. If you have any question, okay, please let me know.
All right, thank you so much, Dr. An, for a wonderful and very informative sharing session. I believe this topic is applicable to every one of us, regardless of our background, because we are all, I believe, road users, and we experience the effect of good traffic management firsthand. So I open the floor to anyone who would like to ask any question to Dr. An regarding either traffic management or roundabout specifically. Any question from the floor? No, none so far. Oh yeah, yes, we have one from Dr. Faiz.
Okay, good morning, Dr. An and Dr. Ilya.
Okay, good morning.
Maybe I have one question. I think maybe this one is no question lah. Okay. Is that if we increase the diameter of roundabout, and let's say we increase the diameter of roundabout, can it will affect the traffic flow?
You mean we increase the limited means what is limited? You mean?
Yeah, the diameter. We make it larger, the roundabout. Okay. Is that can increase the traffic flow?
Actually, as I said in the beginning, roundabout is only for this daily traffic volume between 3,000 and 20,000. If over this traffic volume, we recommend signalized intersection, no more roundabout.
Okay. So maybe the second question. Normally, Perlis we have roundabout without traffic light. Okay.
Yes.
Sometimes when we go to KL, we experience that although there is a roundabout, but we have the traffic light in the roundabout. What is the justification for that?
Okay. Actually, I know one roundabout in Penang near the Queensway Mall. It has 8 traffic signals there. We call it is second stop signalized roundabout. That roundabout actually, I believe, daily traffic volume is over 20,000. So I think signalized intersection can show better performance than roundabout. That's why we put 8 signals there. But Malaysian for intersection at Malaysia, I think use SCAT system from Australia. So it only optimizes delay time only. So I suggest if they use AI algorithm to optimize delay capacity altogether, maybe it can reduce congestion problem. One of researchers said, if we manage a signalized intersection properly, 25% delay will be reduced. Okay.
Okay, thank you very much, Dr. An.
Thank you.
Right. Any other question from the floor? All right. So while waiting for any other question, this is just a follow-up question from what Dr. Faiz just asked. Regarding the traffic light with the roundabout, my question is the traffic light being installed after the roundabout has reached its maximum capacity to manage the traffic, or is it being installed with the planning, the original planning with the roundabout?
Yes, actually, we need actually proper traffic demand process. If we estimate like a future demand properly, maybe we don't need signalized roundabout. Yes, but sometimes unexpected like things. We have like a big shopping mall near the roundabout. Oh, we have one roundabout here near the Hasil in Kanga. That roundabout also face this problem.
So do you recommend that you install add-on traffic light to that roundabout?
Yes, one of my FYP students already conducted the project for this roundabout. It can reduce around 20% congestion with traffic signal, but we don't highly recommend signal light roundabout. Yes, because actually this is not normal roundabout. Right? Yes.
Yeah, because at the end of the day, people are questioning, you will have to abide to the traffic light. So why not just install a traffic light system instead of just roundabout and traffic light?
Because at that time, we estimated in the future, normally we forecast 30 years traffic volume. Maybe something long or some other thing affect the traffic volume. Then we install roundabout first.
Yeah.
And if we have faced this problem, yes, this is another option. But we don't recommend anyway signalized roundabout.
Okay. Yeah. Just you have experience, being brought up in Korea, and then you went to China and Australia. Can you share the effectiveness of roundabout implementation to those countries compared to Malaysia?
What I can say, yes, actually in translation, three E's are important. One is engineering, and second one, education. Third one, enforcement. But these three E in Malaysia need to be improved a little bit. Because when I see it roundabout user, sometimes they are confused the roundabout rule. Also, they keep changing the lane inside the roundabout. It will generate congestion and it will affect, like a road safety issue. Yes, but like as you know, in Australia, very, very different. Each intersection got speed camera, right? And camera for like a traffic sign signal. Also, before entering roundabout, they already indicate the direction for each lane. But Malaysian roundabout, I think we need
to improve more.
Yes.
Right. How is it in China and also in South Korea itself?
In China, like in big city, we don't have roundabout because always everywhere, the traffic volume is over 20,000 vehicles per day. Nowadays in Korea, many like suburban area, we have roundabout. But still China, now roundabout is not good. Too many cars. And, yes.
Yeah, so at the end of the day, we will need to reduce the number of vehicles.
Yes, it can be. It is another like a field in transportation engineering.
True.
Public transport.
Public transportation, yes.
Yes. Maybe in the future, I don't know when, but Malaysia also face and enter this second stage, transportation management.
Yes, true.
Yes. So we need to prepare for this stage. Yes.
All right. So if there's no more question from the floor, I think we can wrap our presentation for today. If everyone can just fill in the attendance form. I think that's it for today. So thank you for attending today's talk. Thank you for our speaker, Dr. An Hong Ki, for his wonderful sharing. And I thank everyone for joining us this morning. All right. Thank you all. Assalamualaikum.
Thank you.
Okay, before that, before we end our webinar session, so I just want to thank you, Dr. Ilya, for moderation of the webinar. And then I think we can have a short photo session. So everyone, please, if you can, open your webcam if possible.
Maybe Dr. An needs to stop sharing, I think.
Okay.
Yes, yes. Okay, let me set the setting first. Screen. Okay. All right. So sorry, I'm looking for the screenshot. Let me give me a minute, please. Where's the button? Where's the button? Okay. Guys ready? Okay. 1, 2, 3. Okay. Okay. So thank you very much to everyone who have joined this webinar. So to conclude, we hope that you have found this webinar informative and helpful. So if you are interested in learning more, feel free to join us again for our next webinar session, which we will update on our respective FKTA social media pages, such as Facebook, Instagram, and TikTok. So please don't forget to follow us for more info. Links can be found in the message box. So with that, thanks again for joining us and have a great day. Salam Jumaat Barakah. Assalamualaikum warahmatullahi wabarakatuh.